Welcome, welcome to the construction safety management class this afternoon. We're going to be doing a live demonstration of how you wear fall arrest equipment, and we're going to also be talking about the fall arrest versus restraint, and then just the basics of fall protection. I have here a certified safety professional, Isaac Ruiz, and he at 27 became a certified safety professional. He will have his own company before long, and he and I work well together out in the field, and I chose him because of his professionalism. So Isaac, before we get started, I have one question I want to ask you. What's the difference between fall restraint and fall arrest?
Great question, brother. Great question. So, to put this plainly, the difference between fall restraint and fall arrest. Fall restraint systems are systems that are designed to prevent the worker from going over the leading edge. They usually have a capacity of 3,000 pounds per anchor, versus a fall arrest system is designed for when the worker falls over. It's designed to stop them, arrest them from hitting that ground. And those systems are at a 5,000 psi on their anchorages.
When you're looking at fall protection, the last thing we want to do is put them in a harness. What are some of the other control measures that we normally use besides the PPE?
Definitely, yeah. So first things first, we want to make sure we have guardrails installed. If we can do that, guardrails are the best type of fall protection we can use. But besides going to a fall arrest system using a fall harness, if we can't use guardrails, by any means we want to try to have some type of dead weight, maybe to have guys attached to with the harness. We want to try to eliminate the fall hazard if possible, taking the entire hazard of falling off even happening, things like that.
Okay. And then tell us a little about some of the measures that you're using on your current job.
Yeah.
I know you're using something a little different that you and I would not prefer, but it's best. Sometimes you got to, management is in control, and we as safety people have to go with whatever they decide sometimes, even though we want to go the more stringent.
Right, yeah. So on our job site, we're actually using what the industry refers to as a warning line system, WLS system. Okay, these systems are designed to be 6 feet away from your edges. It prevents guys from going over their leading edge. They usually require a competent person to be up there supervising the entire process to make sure no one goes past that warning line. They definitely, Brother Jeff, they definitely are the ones you don't want to use. A lot of fault with these systems are the competent person may not be watching his guys, and he may be able to go past that system, and he may still fall off of it. So, although it's not the most preferred one, many folk do use it as far as cost-saving benefits.
So tell us a little bit, if you don't mind, CSP Ruiz, tell us a little bit about fall protection, the basics of fall protection from what either the core or the OSHA requirements.
Yeah, so a couple of very basic things. Fall protection, first off, when it comes to OSHA, they've delineated as 5 feet or 6 feet. M385, though, is very specific. We go with 6 feet on our fall protection requirements. So once we get above 6 feet, 100% fall protection at all times. Falls are actually one of the leading one of the leading OSHA fatal fours when it comes to construction. So we definitely want to make sure that whenever we deal with any kind of falls, that we take it very seriously. A couple of other basic things we want to know when it comes to fall protection systems is we want to make sure the system that we implement is both effective at being safe, but also efficient for the workers to be able to work out of. We want to make sure their harnesses are inspected. We want to make sure that our workers are trained on how to use fall protection systems. And above all else, we want to make sure we have a work plan in place, or if you're on an EM385 project, an AHA fall protection plan detailing what we're going to do on our job sites prior to anybody even starting on those fall hazards.
So in the fall protection plan or the activity hazard analysis, what are some of the things you'd be looking at, if you don't mind sharing?
Yeah, so a couple things I'm looking at here. First things first, I want it to be specific to the job site. Okay, so one thing that we find that's very, very common in the industry, and one thing that we kind of frown upon, is a lot of folks have generic fall protection plans that they just submit for every job site. Okay, we want to get away from that. Our job sites want to be specific to our hazards so that we may know exactly what we're going to be dealing with. Some jobs have areas where a warning line system might not be the best option, versus others may be a guardrail, a fall harness, or other type of systems of fall protection as far as personal fall protection arrest systems, PFASs. Okay. When I'm looking at my fall protection plan, I'm looking for the competent person. Who's my competent person in charge of this? I have to make sure that that man is on site at all times. If he is not on site, we cannot have any fall protection work. And lastly, once I'm looking at my plan, I want to see my certificates. I want to make sure all the guys are trained. Do they know how to put a harness on? Do they know what the OSHA says about fall protection hazards? Things like this.
Oh, who inspects the fall protection gear? As far as the harness and also the anchor points, who inspects those?
Yeah, so as far as harnesses go, we want our competent person to inspect our harnesses. Okay, these harnesses should be inspected prior to each use and signed off on the tag at least every 6 months. When it comes to our anchor systems, same exact thing. We want to make sure our anchors are inspected by a competent person, but we want to make sure that our anchors are tested, that they can hold the strength required. Okay, it's very hard to tell visually if something is strong enough. So for these type of procedures, we normally bring in an engineering lab that can maybe do a pull test or a strength test to figure out what the PSI is on that anchor to make sure it's at 5,000 for fall arrest or 3,000 for fall restraint.
So if we cannot put them in a fall protection system or a fall arrest system, then we could use other measures like a self-retracting lifeline or whatever. Can you tell us about at what level that will catch them if they put the self-retractable lifeline on?
Yeah, so self-retracting lifelines are very common in the industry. Normally they go by yo-yos, is what a lot of people call them in the construction world. How these yo-yos are designed, let's say for example I have a 25-foot yo-yo. We're dealing with a worker working on a 12-foot leading edge. If that worker were to fall off the leading edge, the yo-yo is designed to automatically stop him, almost like a seatbelt does in a car, from falling over the edge. If he falls, the yo-yo will stop him in his fall, hold him in place until self-rescue can come, or other means of mechanical means for rescuing that worker that just fell.
Are these normally used in a vertical application to prevent the yo-yo, the swing effect of them once you is it normally in a vertical, like you're climbing up a ladder, you would put your retractor above it?
Yep. Yeah, so our yo-yos, we actually want to have them above our anchor point, our de-anchor on the back of our harnesses. Okay, so we want to avoid any type of swing hazards or pendulum swings. So when it comes to vertical application, you definitely want to have it above you. You do not want to have your yo-yo below you or below your D-ring on the back of your harness.
I know in the EM3511 it talks about the free fall distance. It talks about where you tie. Let's say you're working on a 20 feet high roof. What kind of application will we use at 20 feet?
Yeah, so at 20 feet, we want to take into account a lot of things when it comes to EM35 and calculating that free fall distance is what we're talking about here. So first things first, we want to take into account the height of the worker. For this particular purpose, I'll say 6 feet is probably the most average size of most construction workers on site. Now, once we're working off of our 6 feet, let's say that our contractor decides to use a 6-foot lanyard with a self-absorbing sock lanyard built into it. These lanyards, once they deploy an extra 3.5 feet. So we had a 6-foot lanyard with that 3.5 feet deployment. That now brings us up to 9.5 feet. Plus the 6 foot of the worker, that brings us now to 15.5 feet. So that worker working on a 20-foot roof would have 4.5 feet before he hits the ground of extra play space that we can work with. So that is how we're looking at our fall protection systems and determining which system is correct. If we decide to use a 10-foot ladder, a 10-foot lanyard on this, it would not fit it as a 10-foot lanyard plus the 3.5 feet. We'll bring them at about 19.5. So it's dangerously close, and you don't want to play those kind of games when it comes to fall protection.
Good answer. When we start looking at fall protection and working on real high rises, there's sometimes that you will be able to use some lifts. I know you're familiar with the area lifts and the scissor lifts. You explain a little bit about either of those and why you like those.
Yeah, so when it comes to aerial lifts or scissor lifts, it gets a little bit tricky when we come to our OSHA interpretation. So OSHA says that because they're inside of an aerial lift or a scissor lift, the guardrails built in don't require fall protection. However, once we get onto EM385 project sites, we automatically want to tie off inside those anchor points in each of those aerial lifts at all times, okay? Now, when it comes to man baskets have built-in anchor points usually on the railing that you can tie off to. In addition to the worker being fall trained on how to tie into that, we also want to have an operator trained for that man lift or that scissor lift as he's working. They definitely are the best approach when you're getting into areas that are very difficult to access or more hazardous to access. Man lifts are my personal favorite. I like the rough terrain ones that can handle the mud. Don't want to have one that's built for concrete only, as it will get stuck inside of the mud.
Do some of those have outriggers?
As far as man lifts go, we do have a couple of lifts that do have man riggers or outriggers in them that can be deployed. These are normally specialty type of ones though.
Yeah.
And if they're found on a job site, it'll probably be on a job site that has a very high access area.
Okay, so if you could, would you mind showing us how you inspect the fall protection equipment and how you don it, and what would you store?
Alright, so we're back here now with our fall harness. We're going to give a quick little class here on how to inspect a fall harness. So this here is our basic Miller fall harness right here. A couple of things that we want to look at prior to letting a guy wear this bad boy. We want to make sure when we're looking at our webbing here. So when I say webbing, I mean all the strapping that's on this harness. Every single one of them. We want to inspect all of the strapping in here to make sure there's no cuts, frays, any chemical solvents that may have fell on that and damaged it. So as we're looking at it, and maybe you can come join me in here, we can both look at it together. We'll inspect this to make sure there's nothing going on with our webbing. So as I'm looking around here, I can tell we're looking at this strap, nothing going on here, on the back of it. Likewise, same thing for the other one. Turn it around, looking up at the very top of it, looking at all my webbing, and it appears, after doing an initial assessment of this, that there's no cuts or frays seen on this harness. So that's step one. Step two now, we want to look at our D-ring here on the back of it, as well as our buckles that we have for our harnesses, okay? Now, when we're looking at our buckles and our D-rings, the main thing we want to look for, especially because we live in Hawaii, is a lot of rust. So sometimes things rust out. If your harness were to rust out, that could cause this to break. We definitely don't want that being involved with the worker. So I inspect my D-ring now. I see there's no rust on it. Looking at my buckles here, my connectors, and it appears that there's no rust on this. So far so good. We're 2 for 2. That's a good harness, okay? Lastly, what we want to do is we want to check our inspection tags. Now, the inspection tags are very difficult to locate, but we'll make it real easy for this one. On this one right here, our inspection tag is going to be found right here. And this one actually has a label that says do not pull, but open this. So now we can open this bad boy up, and we can check out our inspection tag. We can zoom in here with the camera. You guys can see what this looks like. Our inspection tag is found on the inside of this. It's a very simple tag that says what standards this harness is conforming to, the weight limit of it, as far as 130 to 310 pounds. We keep going through it, and we find our inspection chart, and we find a no-no in the field of safety. So it appears that this particular harness has not been signed off on or inspected. That is something that we want to have addressed prior to letting the guy go out there and use it. The rest of these in here are just little diagrams on how to use the harness, so it comes with a nice friendly how to use inside the labels, and as well as some other protection methods. Very simple.
Here, Isaac, you've got your fall harness on. Show us where you're going to hook up
so
your lanyards.
When it comes to our harness right here, it's very easy to know what we're going to be hooking up to. I'll turn around and show you a better view of it. It's going to be this D-ring that you can see back here. This is the D-ring right here that's going to be designed to keep me. Once we have our lanyard attached to it, it holds me in place as I'm walking around up on roofs or wherever my fall hazard may be. Right inside here on this D-ring is right there. It's important to note you cannot have 2 people tie off to the same anchor point though. So we want to make sure we have 1 D-ring to each anchor point.
So should you fall from a roof or whatever, there has to be a rescue person come up that's trained, and I know the standard is Z359 tells you everything you got to do about the competent person, qualified person, rescuer, etc. Okay, so what are the hazards of fall protection when you're out in the field? And then the last question I want you to answer besides the hazards that you see out there is, have you ever seen anyone fall? And tell us about that.
Yeah, so a couple of hazards that we have out in the field when we're using fall protection is mainly going to be that workers are not aware of how high their fall is. So if we have a worker working about 10 feet up in the air, we take our free fall distance into effect. We know that you need at least 15.5 feet. Once he hits the ground on a 10-foot fall, his harness is not helping him at all. It's actually just there as a false confidence. So what we want to work on as safety professionals is making sure that our harnesses and our lanyards that we put out there are of sufficient length to prevent the worker from hitting the ground. In addition to that, we also see a lot of workers that are untrained. So you see a lot of guys walking around roofs that don't know how to use a harness, don't have the training to even be putting a harness on, and things of that nature. As far as seeing a worker fall on a job site, luckily I have not been on a job site yet where a worker has fell. I'm hoping to keep it that way. But if I do have somebody fall, I'll be sure to come back and talk to you guys some more about that.
How much training have you had to be a competent person for fall protection?
Yeah, so I've had, based off of EM 385, on our fall protection section, I had to have documented at least 24 hours of training. So I've received a 24-hour training. In addition to that, I'm also qualified through my degree that I've possessed for safety management and my certified safety professional designation in regards to the safety industry.
So what's the highest building that you've worked off of? I know in construction sometimes it goes from the ground up. But there are sometimes you'll be working off of really high buildings.
Yeah, so I've had the pleasure to work off of a 60-foot building. That's very, very high for me. When these winds come into effect on Hawaii, that's also a hazard that a lot of people need to take in. I came on this job site because the guardrail system that we had in place actually fell off of the roof and damaged nearby contractors' vehicles. So my job was to come in, reassess our guardrails, and figure out what was going on with the system and correct that. But that was a super high roof for me.
And then in closing, fall protection is, as you mentioned earlier, falls continue to be one of the highest hazards here in Hawaii and in other places. Do you believe that the workers that are coming on the projects, the real heavy duty workers, is there any limitations for them? Do we have to have I know there's some restrictions around 1,800 pounds for the users, and then for the personal fall arrest, you've got 5,000 pounds for your anchorage. So where would they anchor? And tell us a little bit about the extra heavy duty guys that might be working.
Yeah, so a couple things. When we got those bigger set guys, those big Samoans as we like to say it, we want to make sure we have the right harness for them. So if you got a guy that's 6'5", 320 pounds, he wouldn't want to fit in, if you can see on this tag right here, a small medium harness. Okay, that would be the wrong harness to put on him. Definitely don't want a guy walking around in one of those. So we want to make sure for those bigger set guys that we have the right harness for them. Most of these harnesses are designed with their weight in mind, so they may have a weight load capacity of up to 400 or 500 pounds, so the harness will be safe for the worker. And then we really want to make sure our anchor point is 5,000 pounds. We want to take into effect gravity when a worker falls that heavy. If it's not 5,000 pounds, if we can go heavier, then we can go for it. There's nothing wrong with exceeding the regulations, but we definitely want to make sure our anchor points are tested for at least 5,000 pounds when we deal with these big guys.
So this engineering class at UH Manoa, is there anything you would like to share with them as they come out? Some of them may be safety engineers, civil engineers, construction engineers. Is there anything you would like to say to them about construction safety?
Yeah, so first things first, construction safety is a growing industry right now. I can tell you that if you guys have chosen safety, all my future safety professionals here, you're definitely in the right field. One thing that I will say that us as safety professionals have to work on is our communication skills and our interpersonal skills. So we don't want to go on job sites. So previously, safety professionals have had a stigma of being a safety cop, where they come on and guys are afraid to talk to them about safety problems that are happening. So we want to break that barrier. We want to make sure that we're able to talk to guys. Guys are comfortable talking with us, so we can make the job site a lot safe as they're working. Lastly, when it comes to fall protection, for all of my safety professionals and engineers out there, you can't just tie off to anything. So that's one of the main concerns here. Some guys will tie off to copper pipes, fire sprinkler lines,
Scaffold systems?
Scaffold systems, vent hose coming out of the roof.
Electrical conduit?
Electrical conduits, exactly. So we want to make sure that what we're tying off to is an approved anchor point, okay? And although I might have the experience and I might be a certified safety professional, I can't make that call and tell you what is strong enough for that. For that, we'd have to bring in an engineer and have our anchor points tested. So
structural engineer for integrity.
Exactly. We want to bring a structural engineer to come in. Who knows? Maybe that fire sprinkler line is strong enough, but you don't want to make that call. There's too much liability in that. We want to make sure that we get rid of our liabilities on our job sites.
So, having worked with Jeff Cochran out in the field, what are your thoughts on how tough he was on you when you were working out there as a safety professional?
Yeah, Jeff Cochran, all the people in the class right now, let me tell you something. You're learning from a very, very intelligent man. You're learning from somebody who knows his regulations like the back of his hand. I don't know if he's been able to spit them from memory like you guys, but back when he was working on our job sites, he would tear us apart. But it was good. It's a good learning experience. So working with Jeff Cochran was a definite big help for me in my career. I learned a lot about safety regulations. I learned a lot about how to implement these safety regulations. I would recommend that if any of you have the time to speak with Jeff after class, talk with him, pick his brains about all the safety things you can. This man is very, very knowledgeable and had a lot of years in the industry, so don't let that go to waste.
Should some of these engineers want to go over and get a CSP or CHST, tell us a little bit about the CSP exam.
Yeah, so the CSP exam. So for all my guys that are graduating college, luckily you guys are able to get what they call a GSP, or a Graduate Safety Professional designation, as soon as you graduate college. Once you get that, you got to make sure you have 4 years of experience and you can go take your Certified Safety Professional exam. The CSP exam is about 200 questions. They give you 5.5 hours to answer all 200 questions. All you have to do is get a passing score of, I believe, 60%. So it's not that difficult, but the questions in there are very, very difficult. So make sure you're studying up on your study guides. The BCSP usually sends these out, but it's a very attainable goal, and the industry definitely does need you all.
Thank you, Isaac. I cannot ever say thank you enough for this presentation. I know, that having worked with you, how professional you are, and we thank you for this. And you engineers, when we get into fall protection, which will start next week, Thursday, you'll get to see this video. We wanted to bring it to you because you didn't get to go to the field. But this training right here is something that's invaluable. And once we get it ready for you, we'll send it to you next week, Thursday. I want you to remember to look at EM 3511, Section 21 as the Bible, because you never know. You may be working as an engineer on a high-rise down in Waikiki or somewhere, and there's several things we got to do. But thank you, Isaac, and I appreciate it.